Hello everyone, in today's topic, we are going to talk about limits of trigonometric functions. So first, let us have some identities that will help us to determine the limit of a certain trigonometric function. The first one is limit sine x over x as x approaches 0 is equal to 1. So here's the proof. Using your calculator, and it must be in radian mode or rad mode. To set it up, you press shift and then the mode or set up, then choose number 4, which is the rad. So setting your calculator in radian mode, type sine 0.1 divided by 0.1. It will be equal to 0.9983 and approximately equal to 1. So as you can see, as the limit approaches 0, it is equal to 1. And then if we have another one, so 0.01, so sine 0.01 divided by 0.01 is equal to 0.99998, which is approximately equal to 1. So that is the proof why we say that limit sine x over x as x approaches 0 is equal to 1. We can also use like this, limit sine u over u as x approaches 0 is equal to 1. Now let us have another identity. So we have limit 1 minus cos x over x as x approaches 0 is equal to 0. So why? Using the calculator in radian mode. So we have 1 minus cos 0.1 divided by 0.1. It is equal to 0.05. And then 1 minus cosine 0.01 divided by 0.01 is equal to 0.005. And then if we have another point nearest to 0, it is 0.0001. So if we have 1 minus cosine 0.0001 divided by 0.0001, it is approximately equal to 0. Okay? So 0.05, 0.005, 0.0005 is approximately equal to 0. Now let's find the limit of the following. Limit sine 5x over x as x approaches 0. So first we are going to multiply it by 5 over 5. Since 5 over 5 is equal to 1, so the value does not change at all. It is equal to limit sine 5x over 5x as x approaches 0. So from here, we are going to have to multiply it by 5. And then let u is equal to 5x. So we are going to replace 5x as u multiplied by 5. Since we have the identity limit sine u over u as x approaches 0 is equal to 1, so this one will become 1 times 5. So the limit sine 5x over x as x approaches 0 is equal to 5. So let us find limit sine 2x over 5x as x approaches 0. So first we are going to multiply it by 2 over 2. Then we are going to interchange 5 and 2 so that we can have limit sine u over u. So we have limit sine 2x over 2x as x approaches 0 times the remaining factor, which is 2 over 5. From here, let u is equal to 2x. And remember that limit sine u over u as x approaches 0 is equal to 1. So this becomes 1 times 2/5. So the answer is 2/5. Now let us have another one. Limit sine 7x over sine 3x as x approaches 0. From here, we are going to multiply it by the factors of 7x and 3x. So times 7 over 7 times 3 over 3 times x over x. Then we are going to reshuffle. So we have limit sine 7x over 7x as x approaches 0 times 3x over sine 3x times 7 over 3. So let u be equal to 7x and v is equal to 3x. So we have limit sine u over u as x approaches 0 and limit u over sine v, limit v over sine v as x approaches 0. Then we have 7 over 3. I didn't write a limit of 7 over 3 as x approaches 0 because we all know that limit of a constant is equal to a constant. So from here, since limit of sine u over u as x approaches 0 is 1, and limit v over sine v is equal to 1, so 1 times 7 over 3, so the answer is 7 over 3. Now let us have limit tan x over x as x approaches 0. So we are going to rewrite tan x over x as limit tan x over 1 as x approaches 0 times 1 over x. Take note that tan x is equal to sine x over cos x. So we are going to rewrite limit tan x over 1 as limit sine x over cosine x as x approaches 0 times 1 over x. Then we are going to have limit sine x over x as x approaches 0, so that we have 1 in here, and we have 1 over cosine x. So 1 over cosine x is equal to 1, okay? So limit sine x over x as x approaches 0, we all know that it is equal to 1, and limit 1 over cosine x is equal to 1. So 1 times 1, the answer is 1. So let us have another one. Limit tan 4x over 3x as x approaches 0 is equal to limit sine 4x over cosine 4x as x approaches 0. Since we all know that tangent is equal to sine over cosine times 1 over 3x times 4 over 4. So we have limit sine 4x over 4x as x approaches 0. This will become 1 later on. And we have 1 over cosine 4x times 4 over 3, the remaining factor. So let u be equal to 4x. So we have limit sine u over u as x approaches 0 times 1 over cosine u times 4 over 3. So limit sine u over u as x approaches 0 will become 1, as well as limit 1 over cosine u as x approaches 0 will become 1. So 1 times 1 times 4 over 3, it is equal to 4 over 3. So limit tan 4x over 3x as x approaches 0 is equal to 4 over 3. So let us have another one. Limit sine squared x over x as x approaches 0 is equal to limit sine x over x as x approaches 0 times x. So from here, we have limit sine x over x as x approaches 0 times limit x as x approaches 0. And this is an easy limit. So we are going to substitute the value of your x. So automatically, limit x as x approaches 0 is 0. Then we have the identity limit sine x over x as x approaches 0 is equal to 1. So 1 times 0 is equal to 0. So limit sine squared x over x as x approaches 0 is equal to 0. Now let us have another one. Limit 7 times 1 minus cosine x over x as x approaches 0. So from here, we are going to rewrite it as 7 times the limit of 1 minus cosine x over x as x approaches 0. Since we all know that there is an identity stating that limit 1 minus cosine x over x as x approaches 0 is equal to 0, so we substitute the value. First, we copy 7 times 0, so the answer is 0. So limit 7 times 1 minus cosine x over x as x approaches 0 is equal to 0. Now let us have the last one. Limit 1 minus cosine x over x squared times 1 plus cosine x over 1 plus cosine x as x approaches 0. So from here, we are going to have limit 1 minus cosine squared x, because 1 minus cosine x times 1 plus cosine x, we don't have the middle term, okay? 1 times 1 is 1, cosine x, negative cosine x times positive cosine x is negative cosine squared x. And then copy the denominator or just multiply it, x squared over 1 plus cosine x as x approaches 0. So note that we have the Pythagorean identity, which states that sine squared x plus cosine squared x is equal to 1. Then if we are going to transpose cosine x to the other side, so we have sine squared x is equal to 1 minus cosine squared x. So we are going to put the value of sine squared x in the numerator. So we have limit sine squared x over x squared times 1 plus cosine x as x approaches 0. From here, we are going to rewrite it as limit sine squared x over x squared as x approaches 0 times limit 1 over 1 plus cosine x as x approaches 0. So simplifying further, this can be written as limit sine x over x as x approaches 0 raised to 2. Then limit 1 over 1 plus cosine x as x approaches 0 is equal to 1 over 1 plus 1. So it's just an easy limit. Just substitute the value of your 0. So we have 1 squared because we have the identity limit sine x over x as x approaches 0 is equal to 1. Then this one will be equal to 1 half. So 1 times 1 half is equal to 1 half. Now let us have a short quiz. Find the limit of the following. Limit 8 times 1 minus cosine x over x as x approaches 0 in 5 seconds. That's right, the answer is 0. Find the limit. Limit tan 7x over 8x as x approaches 0 is what? That's right, it is equal to 7 over 8. Now exercise time, do worksheet 8 in the Google Classroom. Please type your name, student number, and class before you answer. That's it for now. Thank you for watching. See you again next time. Please do subscribe to my channel. Bye!